solving chemical problems. Most of the chemistry problems in this course really come down to being unit conversion problems. There are some others that will require specific equations, like converting temperatures requires equations. But there's a technique called dimensional analysis that I'm going to teach you right now that is super, super helpful for solving chemical problems. And it's basically unit conversions, but in a way that you might not have seen before. It allows you to set up the problem just looking at the units without having to memorize an equation or memorize a series of steps or think about, do I need to divide by this or multiply by this? I'm going to show you how you can set the units up so they will tell you where to put the numbers. And it can be tempting, especially in this first part where we're doing things with inches and miles and things that you're familiar with, to say, well, I know how to solve that problem and I'll just do it this way that I've always done it. I'm teaching you this process because when we get to stoichiometry, where you're converting grams to moles to grams, knowing how to convert feet to miles isn't going to help you there. But this technique will work really, really well. So I want you all to give it a try. So units in the calculations act a lot like algebraic variables, those x's and y's, etc. So you can multiply the units, like centimeter times centimeter gives you centimeters squared. They can cancel out, and so we'll just treat them like variables, but they just need to come along for the ride. So what we refer to as a unit equation is basically just a statement of equality. So 2.54 centimeters is equal to 1 inch, right? Those things are equal to each other. We can make that into a conversion factor by turning it into a fraction. So if I take 2.54 centimeters is equal to 1 inch. If I divide both sides by 1 inch, can't write. This side, 1 inch divided by 1 inch, cancels out, right? And is equal to 1. So 2.54 centimeters divided by 1 inch is numerically equal to 1. I can do it the other way by dividing both sides by 2.54 centimeters, and then I'll end up with 1 inch over 2.54 centimeters is equal to 1. This thing here, the conversion factor, is equal to 1 because what is in the numerator, what's on the top, 1 inch, is the same as what's on the bottom, 2.54 centimeters. They don't look the same, but we understand that they refer to the same length, right? So what's on the top is equal to what's on the bottom. So I can multiply something by this, and it's not going to change the length because I'm multiplying by 1, and multiplying by 1 doesn't change something. What happens, though, is that the units change. So any unit equation like this is the sort of thing you might look up in a table. You can turn into a conversion factor, and you can do it one way or upside down. What's important is that the number stay with its unit. So 1 inch, the 1 is always with the inch, whether it's on the top or the bottom. Any questions yet? So most conversion problems have a similar form. You've got an information that's given, some number or measurement with a unit, and then you need to find something in a different unit. So here's an example. How many centimeters are in 12 inches?
2.54.
So I have a number here, 12 inches. So, go through and highlight the numbers, and then identify, what am I trying to find? What's the unit I'm trying to find? Centimeters. Okay. So what I'm going to do here is I'm going from 12 inches to centimeters. I think I'm kind of getting ahead of myself, but I don't care. So this is a path or a plan. This is my, roadmap for how I'm going to do the problem. I've got 12 inches, and I'm going to convert that to centimeters. So the way you convert between inches and centimeters is you need a conversion factor, right? So we know that 1 inch is equal to 2.54 centimeters. We just did that in the previous slide. So like this shows us here, we're going to have our given unit, that's the 12 inches. We're going to multiply by a conversion factor to get the desired unit. So 12 inches, and I'm going to multiply by a fraction, and I want to end up with centimeters. So we saw that this could be 1 inch over 2.54 centimeters, or 2.54 centimeters over 1 inch. What I want here is I want this unit inches to go away. So I want to divide by inches, so the inches will cancel out. And the unit I want is centimeters, so I want to multiply by centimeters. That tells me which of these I'm going to use. I want the one with centimeters on top and inches on the bottom. So 2.54 centimeters per inch. The inches cancel out. And this is what I mean by showing your work with the units. So 12 times 2.54. And my calculator shows me 30.48. How many sig figs should it have? 2. So we could write 30, or we could put it in scientific notation, 30.0 times 10 to the 1. Sig figs aren't the point there, it's just a little practice. Any questions? So for those of you who like lists of instructions, here's your list of instructions. General strategy, and this follows what I've been talking about. Identify the starting point. What are you given? So write down those numbers and their units. We haven't talked about this yet, but sometimes you'll have per units. Those derived units like density, grams per milliliter. Anytime you see per, you're going to write that down, but think that might be a conversion factor. You want to identify where you're going, what you're trying to find, and then figure out a way to get there. Then you solve it following your plan. Use your calculator. Don't do math in your head. Or if you do, check it on the calculator, because it's so sad to do this complicated stuff and then you added 2 plus 2 and got 5. It happens, right? It happens. Use the calculator. Type it through on your calculator twice, because it's easy to make a mistake in the calculator. I thought I pushed a 2, but the 2 didn't show up. Clear the calculator, type it in again, get the same number. And then you should always ask yourself, does that make sense? Like if I end up doing a calculation and I've got a 7-meter tall basketball player, does that make sense? No, that doesn't make sense. So then you go back and look at your work and see where you went wrong. So let's do some practice. Convert 288 centimeters to yards. Well, what am I given? I'm given 288 centimeters. And what am I trying to find? Yards. So I'm going to write my plan or my path, 288 centimeters And I want to convert that to yards. I'm going to write yards over here, because off the top of my head, I don't know how many centimeters are in a yard. Could I look that up? Yeah, I could. But that's not the point. The point here is to learn how to string together a couple of conversion factors, because we'll have to do it later. So this is why I recommend just using that table in your book to look up conversion factors instead of trying to get some really fancy ones. So I don't know the relationship between centimeters and yards, but I know centimeters to inches, right? We just did that one. So I could convert centimeter to inches. Thank you. And that looks promising because this is an English unit and yard is also an English unit. So I was like, okay, I'm getting closer. Well, do I know how many inches are in a yard? 36, right? That's true. What if you didn't? Do you know how many inches are in a foot and how many feet in a yard? Well, let's pretend we didn't know. Do I know how many inches are in a foot? Yeah, there's 12 inches in a foot. We're pretending we didn't know the 36. So I could convert my inches to feet and my feet to yards. You're like, well, this is dumb. Just ask Google. Well, yeah. Solving this particular question is not the point here. Learning the process is, because those later questions, you can't ask Google or any calculator to just do it for you. You have to put the thing together yourself. And so that's what I'm teaching you right now. So this is my plan, and this is really the hardest part of solving the problem, is figuring out how to get from the one to the other. So once I have this in place, I'm just going to follow a pattern of what to do. So centimeters to inches to feet to yards, each of these arrows needs a conversion factor. So I can write my equation out now, 288 centimeters, and for every arrow, I'm going to have a fraction here, times, and a line. That's the first arrow. There's the second arrow. And there's the third arrow, and it's going to be equals at the end. Because this one is where I'm going to convert from centimeters to inches, and then inches to feet, and feet to yards. So from my path, these are the units that go on the top. Centimeters to inches to feet to yards. Centimeters, inches, feet, yards. So I'm just going to write those on the lines. I've got inches and feet and yards. That's easy enough, huh? I came up with this path and I drew this out. I'm just copying the units down in the same order. Now, we need this centimeter to go away. We need it to cancel out. So I want to write centimeters down here so the units will cancel out. Because then in my equation I'll have centimeter divided by centimeter, which cancels out. Now I've got inches, and I want the inches to go away, so I'm going to put that unit down here. And I'm going to put feet down here. And what I'm left with is the unit I was trying to get to. Any questions? This is analyzing the units. Now the units are going to show me where I need the numbers. Here I have inches and centimeters. Well, how many inches are equal to how many centimeters? 1 inch is 2.54 centimeters. So I put 1 with inch and 2.54 with centimeters. I don't have to think. I mean, thinking's good, but unnecessary thinking just makes your brain hurt. Feet and inches. How many feet to how many inches? 12 inches, right, in 1 foot. 12 inches, so I better put the 12 in front of the inches to 1 foot. If we switch the numbers, it's a little ridiculous. 12 feet is equal to 1 inch. No, it's not, right? 12 inches is 1 foot. And then here, how many feet in a yard? 3. So I've got 1 yard to 3 feet. Now I get my calculator, and please do it this way. You take this number, you multiply by the top of the first fraction, then you divide by that one, by the bottom. Multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. You're not going to have a denominator that you have to write down and a numerator and then punch those back in and divide them. You're not going to have to write anything down. Now, do you have to multiply by 1? No, it's not going to change anything. If you feel better just following the pattern and multiplying by 1, you go ahead and do that. So I'm going to do 288 times 1 divided by 2.54 times 1 divided by 12 times 1 divided by 3 equals. And it's kind of giving me a mess, and I'm like, I don't want to write it all down. Well, how many sig figs should I have? I've heard 2 and 1 and 3. Okay, how do we decide? Well, this one had how many? 3. So, kind of, if you're in a situation where you just can't stop and think about the sig figs, or, you just completely forget about them, it's usually safe to go with the same number of sig figs as what you started with. That's always a good idea, good guess. So 3 sig figs here. This one is exact. That's the one between English and metric that is an exact conversion. So if this is a conversion factor that's exact, what that means is it's not going to affect the sig figs. I don't need to look at it. How about inches to feet? Is that exact? Yeah, I don't need to consider that one. How about yards to feet? Also exact. They're defined. So none of those conversion factors change the sig figs. So I start with 3, I end with 3. I'm just going to write down 2 extra digits because that's what I do. And now I'm going to round. So I'm going to keep the second decimal place. The next one is 5 or greater. I need to round up. So the answer is 3.15 yards. Any questions? On question 12 of the worksheet, there's a whole page. It's only 7. There's 7 different unit conversions. And to get credit there, you have to do it using dimensional analysis. You have to set it up like this. Because I want to make sure that you learn how to do it that way. Later, if you choose not to, that's fine, but at least I know you know how to do it. Convert 9,255 cubic centimeters to gallons. I read the problem. I'm going to identify what I'm given. It's the thing with the number, right? This many. And what unit am I trying to find? Gallons. Next is make a path from start to finish. This is a little bit like planning a trip, right? Maybe here I am in Fresno, California, and I want to go to New York City. How am I going to get there, right? There's so many different ways. You could take a train, you could take a plane, you could take a bus, you could drive, and even among those, there's different ways you could go. So you figure it out. And there's more than one good way to get there. So not everybody's path is going to look the same. But the path is going to be limited by what information we have. So I popped this up because that's not something I remember, and that would be useful here. So my path is going to be 9,255 cubic centimeters. That's my place of origin. That's where I'm starting, and I'm trying to get to gallons.
Well, we know 1 centimeter cubed is equal to 1 milliliter.
Right. So 1 centimeter cubed is equal to 1 milliliter. Is that going to help us?
Yes.
Yeah. So we could convert this to milliliters because in that table in the book we have this relationship. Sometimes you can just go from the beginning to the end and everything's nice. Other times you're like, I don't know, start at the end maybe. Well, I found this. This relates gallons to liters, right? This is a metric unit, and that's a metric unit. So if I got to liters, I could get to gallons using this, right? So I went to milliliters, and then I need to get to gallons. I have milliliters, I need to get to liters. Could I do that? Yeah, because I've learned how metric prefixes use. No, I've learned how to use metric prefixes. Okay, so there's my path. Cubic centimeters to milliliters to liters to gallons. Any questions about how I got the path? Okay, so I'm going to write this down. 9255 cubic centimeters. There are 3 arrows there. I'm going to have 3 fractions. 1, 2, 3. This same trail of units, I'm going to write down in the numerator. So I got cubic centimeters to milliliters to liters to gallons. The unit that's first goes to the bottom of the next one. Then this one goes to the bottom of that one. This one goes to the bottom of that one. So we can cancel them out. Cubic centimeters. So those are going to go away. And if I put milliliters down here, those are going to cancel out. And liters down here, those are going to cancel out. Notice I'm just drawing a single line through them. I still need to be able to read what's under there, but that just helps me to see, if you have one in the top and one in the bottom, they're going to cancel out. You can't, if there's 2 in the top, they don't cancel out. So don't do any wishful unit canceling. Units are in place. They're going to tell me where to put the numbers. Well, this one's sitting here staring me in the face. Let's use this one first. So gallons and liters, this one has gallons and liters. So the number in front of gallon is 1, and so in front of gallon, I'm going to write 1. And with liters is 3.785. So what I've done here is I've taken one side of that equality and put it on one side of my fraction and the other side on the other side. So you can kind of think of tipping this, just rotating this to the right so it's not horizontal anymore. It becomes vertical, and it's 1 gallon over that many liters. That's all we're doing. Okay. How many milliliters to a centimeter?
1 to 1.
That one's 1 to 1. And that's one that's easy to forget. Now, milliliters to liters. So to do this, I need to know that milli stands for times 10 to the minus 3. How do we know that? We memorize that. Right? Just the way you memorize your friend's name. This person is called this because milli is 10 to the minus 3 because a bunch of people decided about it. So here I have liter and liter, and in the bottom I have milli. So the top needs to equal the bottom. So on top, what I'm going to do is I'm going to write the numerical value of milli. So I've got 1 milliliter on the bottom. I have 1 times 10 to the minus 3 liters on the top. So the times 10 to the is never with the prefix. The prefix is on one side, the 10 to the something is on the other side of the line. Every single time. There are other ways to do this. You may say, well, I know that a liter is 1,000 milliliters. Great. do it that way. I'm not going to do that in lecture, because even teaching it like this, I find that people sometimes, I don't know what happens. I guess it's what my husband calls a brain fart. And they tell me that 1,000 liters is a milliliter. That's like saying an inch is 12 feet. It's ridiculous. But it's milliliters and liters, and then your brain's like, I don't know what those are. Cubic centimeter is a milliliter, a little tiny thing. You know how big 1,000 liters is? 500 2-liter bottles of soda. Not the same. So if you use the 10 to the exponent that are in the table, and you put that on one side and the prefix on the other side, it will always be correct. I think that's pretty nice. Okay, so now we have to type this into our calculators. This is a number in scientific notation. And yes, you could convert it to decimal notation. And sometimes you will have to do that. But you're also going to have to learn how to enter scientific notation into your calculator. And so we might as well do it now and get used to it. And it's just a lot easier. So to enter this number, 1 times 10 to the minus 3, you're going to type 1, and you're not going to press multiply. Your calculator will either have a button that says EE, or it may say EXP. So you should get your calculator out if you don't have it out, and try this, because sometimes your calculator doesn't want to cooperate with you, and then I can come and have a talk with it and get it straightened out. So you press EE or EXP. Those buttons stand for times 10 to the. So as I push the button, I think times 10 to the, and then I just have to put in the exponent. So on my calculator, putting a negative number in, I'm not going to use the subtraction button, I'm going to use the change sign button. So it might look like this on your calculator. And 3. And press equals. And your calculator will probably show you 0.001. So as I do this problem, 9255 times 1 divided by 1, and I'm going to go times 1 EE negative 3 divided by 1 times 1 divided by 3.785 equals. Again, the calculator's giving me a mess. My starting number had 4 sig figs. So if I just am guessing, that would be a good guess. This is exact, that's exact. Is this one exact? No, but it has 4 sig figs also. So I'm going to need 4 sig figs. It'll be right there. And I'm just going to write down the next 2 digits. And so this is 2.445 gallons. Yeah.
I don't know where they eat. Oh, I guess.
Yeah, okay, so. So I already showed you how to do this, but here's the slide with the words on it. So we can make conversion factors using base units and units with a prefix, like kilometers to meters. Instead of writing the kilo, the little k, we write what it stands for. So 1 kilometer is 1 times 10 to the 3 meters. Because when you look on that table, k means 10 to the 3. So the prefix goes on one side and the multiplier on the other side, never together. There's a way to do it with the multiplier on the other side, but it just makes things more complicated. So we're not going to talk about it. We're just going to do it like this. Okay? Now, what if you have your beginning unit has a prefix and your ending unit has a prefix? Like, what's the relationship here between centimeters and nanometers? Well, there is a relationship. I could figure it out. Or I could just go centimeters to meters and meters to nanometers, which is really easy and actually much faster than trying to go from one to the other. So if you have two prefixes, you're going to do it in 2 steps. You're going to do the prefix to the one without the prefix and then to the other prefix. Any questions? Let's do this one. So convert 5.52 times 10 minus 5 centiseconds to microseconds. So here's my number and unit that I'm given. And the unit I'm trying to find is microseconds. So these are both a kind of second, right? This one has a prefix, and that one has a prefix, and that tells me my path is going to have 2 steps. I'm going to go 5.52 times 10 to the minus 5 centiseconds. I'm trying to get to microseconds. And the one in the middle is a naked second, right? It's just a second all by itself. He's not naked, he's just alone. Maybe he's alone and naked. Maybe he's naked and afraid.
I knew you were going to say that. I had a
Sorry.
feeling you were going to say that.
My husband likes that show. It's so
Why?
stupid. I don't know, it's just so stupid.
It is very stupid. 'Cause
Okay.
it's scripted.
We're back. Okay. So, centiseconds to seconds to microseconds. So, always write that path down until you get good at it. Eventually, you can stop doing that. So, here's my number, centiseconds. 2 arrows this time, 2 fractions. Centiseconds, seconds, microseconds. Centiseconds, seconds, microseconds. Okay? Because there's 2 prefixes. And so then I'm going to take this unit and bring it to the bottom. And I'm going to take that unit and bring it to the bottom. Because I want those guys to cancel out. Okay? Now we're going to use what we learned about making conversion factors with metric prefixes. So we need to know, what does centi represent? It's times 10 to the minus 2. And what does micro represent? It's times 10 to the negative 6. So, as you're learning those, try to think of what it is, guess maybe, and then check in a table. You'll pick them up pretty quick. So here I have centi in the denominator and no centi in the top. So where am I going to write times 10 to the minus 2? I'm going to write it on the side that doesn't already have the C. So I'm going to put it up here. And that's 1 times 10 to the minus 2 seconds and 1 centiseconds. Those are equal to each other. On this one, I have the symbol micro on the top. I can't put micro and 10 to the minus 6 together. They need to be on opposite sides. So times 10 to the minus 6 is going to go down here. That's 1 microsecond. It's 1 times 10 to the minus 6 seconds. Okay. So this one's going to show you if you're using the wrong button for your scientific notation. So do this with me and see if we get the right answer. So I got 5.52 EE negative 5 times 1 EE negative 2 divided by 1 EE negative 6 equals. Did your calculator give you that, 0.552? It's gonna give you 552, but it might be a lot bigger or smaller, or the decimal point might be in the wrong place. We can fix that. The nice thing about this is converting in the metric system, you're never gonna get all those crazy decimal places. It's just gonna give you what you started with. I started with 552 with 3 sig figs, I end up with 3. So any questions about that one? There's one like this on your worksheet also.
I got this.
Okay, let's pause. Okay, sometimes we have units raised to a power that we have to convert. And when we make these conversion factors, we're going to have to raise both sides of the conversion factor to the same power as the units are raised. So the example here is square centimeters to square inches. I can start out with the relationship between centimeters and inches. And if I need square inches, I'm going to take this whole side and square it. I'm going to take that whole side and square it. The number is squared and the unit is squared. The number is squared and the unit is squared. 1 squared is still 1, and so it kind of messes with us, but there it is. So a square inch is 6.45 square centimeters. That's because of geometry.
I thought we were only going to 1.8.
Isn't this 1.8?
It's 1.9.
Well, we're also doing 1.9.
1.10 as well?
I don't know, I just know what the next slide is.
All right.
I like to make my life more interesting that way. I don't look at the slides beforehand, I just get up here and, oh, this is what's next, this is what we're gonna talk about.
Yeah, the problem is
Cheap
I-
thrills. Okay, so how many cubic centimeters in 2.11 cubic yards? So I have cubed units here, right? Well, again, let's identify what we have. I have this many cubed yards, and what I'm trying to find, cubic centimeters, and I'm going to make my path. So 2.11 cubic yards. And I'm going to have to convert that, and I'm going to end up with, I want to end up with centimeters. Well, there were 36 inches in a yard, right? We didn't use that last time, but we talked about it, and now we're not going to pretend that we don't know it. We do know that. So we could go from yards to inches and inches to centimeters. But that's cubic inches and cubic centimeters. So if you can do it with the regular length unit, you can do the same thing with the cubed or squared unit. So 2 arrows, 2 fractions. So this is going to be inches, and this is going to be centimeters. And I'm going to have yards down here and inches down here. To get the cubed units for my conversion factors, I need to cube the units in the conversion factor and the numbers in the conversion factor. So now these units are going to cancel because I've got yards cubed and yards cubed, inches cubed and inches cubed. So how many inches per yard? Well, there's 36 inches in 1 yard. But when I do this on my calculator, this is 36 cubed. Many of you have a button on your calculator that you can raise something to a power. You could use that. Or you can multiply by 36 3 times. You could do that too. And then over here, the centimeters to inches, 2.54 centimeters is 1 inch. So 2.11 times 36 cubed times 2.54 cubed. Big old number. It's a ridiculous number of sig figs. Exact. Started with 3, I should end with 3. So,
We should probably convert this to scientific notation.
yeah, we should convert this to scientific notation so we don't convert a million to 1. Yes?
To start off, just for calculation purposes, would you cube the 2.11 as well when you're starting?
That's a great question. So I'm talking to you about cubing things here, and it's a very natural extension to see this, and oh, this, I should cube everything here too. No, don't. So this is written 2.11 and yards cubed. The exponent is on the yard. It's not also on the number. If they wanted it to be on the number, and that could happen, then it would be written with parentheses. Oops. Then you would cube the number. Great question, thank you for asking. Yeah, so that's not what we want. So here I'm rounding. I don't need to identify what place it is. It's bigger than the ones place. So I could possibly make a mistake and round, is that 1.6 million to 161. I don't want to do that. Let's put this in scientific notation. 1.61. The 1 stays a 1 because the next one is less than 5. And then times 10 to the. And then, so I'm putting the decimal point over there. 1, 2, 3, 4, 5, 6. Should that be positive exponent or negative?
Positive because it's a big number.
Positive because it's a big number and I feel positive about big paychecks. Okay, so there's our answer. Any questions? Could you write that out in decimal notation? Yeah, you could. My personal rule of thumb is if there's more than 3 zeros, put it in scientific notation. Because you look at those zeros and it's just hard to see how many.
Can you go back to the slide?
Yeah. That one? Mm-hmm.
That's a lot of wine grapes.
Blah, 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 blah. I don't want to do all of these.
Last one looks interesting.
Let's do this one. So there is an equation for density, and students always want to rearrange the equation when they're doing things with density. Please don't. The only time you need the density equation is if you're calculating the density. Here, we are given the density and we're calculated something else. The density is just a conversion factor. So we have a drop of gasoline has a mass of 22 milligrams and a density of 0.754 grams per cubic centimeter. What is its volume in cubic centimeters? This is beginning to sound more like those, the train is traveling kind of problems. So here I have now 2 numbers. So I'm going to highlight both of those, and I'm trying to find volume in cubic centimeters. So I'm going to write down those numbers over here. I have 22 milligrams, and I have 0.754. That is written with the fraction horizontal and a slash, because it's easier to type. But we're not typing now, we're writing with our hand. So let's make it a vertical fraction, like it should be, so that our brain recognizes that's a fraction. what number would be in the denominator if we wanted to put a number there? A 1. That kind of looks like a conversion factor to me. It is. Density is a conversion factor. It is specific to the problem you're working on, but that's a conversion factor. So here I've got two kinds of units. I've got just regular units, and I've got a unit that says per in it. I'm going to start with this one. The other one's going to be a conversion factor. So I've got milligrams, and I'm trying to go to cubic centimeters. Well, this we probably need to use. This has cubic centimeters in relation to grams. So I can use this to go back and forth between those two. So if I could figure out what the grams are, I could use this to get the cubic centimeters. Can I go from milligrams to grams?
Yes.
Yeah. It was a really long arrow, but it's not that hard. So 22 milligrams, 2 arrows, 2 conversion factors. Milligrams to grams to cubic centimeters. I'm going to put the milligrams down here and the grams down there. I look it up if I don't already know it. Milli represents times 10 to the negative 3. So milli is in the bottom. 1 milligram is 1 times 10 to the negative 3 grams. Prefix and 10 to, they'll go on opposite sides. And then this one, I've got that density. The number is with grams, and so it has to stay with grams. And 1 is with cubic centimeter. So 22 times 1 EE negative 3 divided by 0.754. I started with 2 sig figs. I'm going to end up with 2 sig figs. That would be cubic centimeters. Is that a reasonable reasonable size for a drop of gasoline?
Yeah.
Probably. It's really small, right? Questions? I know I talked so long about this, didn't I? That's even with skipping most of the slides.
Yeah, we're only gonna have an hour and a half. Well, almost 2 hours. Worksheet.
Okay, so I have done those other slides at other times, and if you want a video showing how to do any of those, just let me know, and I'll find it for you, or I'll make a new one. So, oh wait, these are the dirt pouches for you. To show you this thing I did. I still need to publish this. Today's Thursday, right?
Yes.
So I'm gonna make this due. I'm gonna give you a week. I hope that has all the changes that I put in there. Okay. So I don't really have any instructions in there. yet, but, so, you do the worksheets, and then you type the answers in here. Just do a couple of them, submit the quiz, it'll tell you if they're right or wrong, it won't give you the right answer. If it's wrong, that means you try again. There's a couple of them that, if you might need to use scientific notation, I gave you something here, so let's use the caret as the exponent. There's one here,
Are we using the asterisk or like an X for the times?
an x.
Okay.
Yeah, so if you were typing 4.1 times 10 to the minus 2, you type in 4.1 x 10 caret negative 2.
You use quotations or am I just blind?
Well, those are quotations, but that was to set it aside,
Okay.
so. Okay. So, you can work together, but make sure that you understand. And I'm not gonna guard the door, 'cause that's done. But, I do expect you to stay. Would you like a stapled copy? I do expect you to stay until class is over, or until you have finished the worksheet.
Can you get one more of these?
It's one thing, but it's set up so that you can do it as many times as you want.
Okay, and then
It'll keep the highest score. Because unfortunately, each time you submit it, if you open it up again, you have to type all the answers.
and then you want a picture of our work.
Yeah, and then you're gonna take pictures of your work, and that's submitted at the last question. So don't do that until you're done. Sorry, I meant to do this during your break, but other things. As they kind of always do.
Wait, for temperature, are we using Kelvin for this or are we using Celsius?
It says
The
a
metric system is
metric
Celsius.
unit.
Okay, so what is Celsius?
gotta have my own.
Just convenient. Yeah, when I'm home, one
No, they're
I usually keep two of them, like one on my desk, it would work, so just in case they get damaged or that, I have that one there.
And if anybody wants to get the $5 lab coat or $5 goggles,
Sorry, the bookstore doesn't get cash back.
Yeah, I'll want that.
okay, I'm gonna go get them in.
Okay.
Sid saves. For this one.
I have a few goggles for this, we only have 2 lab coats left.
They're not giving you the new ones?
This one's 3XL, but it's pretty.
No, no.
And this one is double XL. Might fit you. Try that on. Good on you. Do you need goggles too?
No.
Okay. The $5.
Is that for you?
Yeah.
For sure. Do you have change?
I think I can get change up. Put this one back.
CK through 12 has a, like on their official website, they have exact numbers, I think we finished them at 60. It's a government foundation, I think.
Oh, I had a question. Also, do you want the money to get changed or?
I have to go get it.
Okay, for these, did you want, because you said these are abbreviated, do you want the full name with the, prefix? Like
No.
nanograms?
No, you can just, so it's grams, so just write NG.
Okay, sure.
Hey, how about we, where'd you go? God damn it. The one time you have to ask the question, she disappears.
You were looking at the PowerPoint on your, or on the computer, right?
Mhm.
Could you locate or tell me where to locate it here? I was looking.
Modules, preview.
Oh, wonderful.
There we go.
Perfect. Thank you so much.
You're welcome. I don't know if you would count the extra 5 zeros for this notation, because if we were to write it out, it would show the zeros after with this. Wait, no, hold on. This will move it to the end. 5. This one. Okay, so these ones, no. This one, yes. Well, yeah, because if you write this out, it'll move it all the way to the end, and then it's just 6, 102. Yeah, it's gonna move it all the way to the end, and just have 0. But I think for this one, yes. To write it out, you're just gonna move it this one. So. I'm gonna say. Oh, they'll still be trailing, so no. Or they'll be, the ones in the front. So still. Yeah. I just wanted to ask her how it was, just put it in.
On the worksheet, do you want us to write out like this entire answer and then put with the correct suffix, or do you just want the correct answer?
That's kind of up to you. What I would do is I would write out the correct number of significant figures with 2 extras and then round it.
Okay.
So then if you're looking over something and you realize, oh shoot, I did that wrong, you could probably go back and fix it without redoing the calculation. But you'll just have to type the number itself, the rounded number, into the computer.
Okay.
So, don't convert these. Yeah.
Real quick, how are we gonna put infinity into that,
Infinity is a word you could type.
oh,
So
okay.
you can also do it with, I don't know if this program works, but if you put 2 lowercase o's next to each other, sometimes it'll convert into, but I don't know if this one does.
That one, it won't,
Okay,
yeah.
alright.
So just a note, when you're doing, it's page 2,
Page 1. Bottom, kind of.
page 2 and the top of page 3, there are units on there, but there's no unit converting that you should do. Just include the correct units in your answer, but don't convert units, okay?
Kind of dumb. So for this one, I got 2 different answers. If I add it, if I were to put it in the calculator, how should I do that? But if I were to do it, addition versus this, try to.
Okay, so this is minus 9.1 and plus 105.
Okay.
It's not minus the quantity, 9.1 plus 105.
Okay, so just start from left to right.
Yeah, so, this calculator, when you've got something like that, most of the time you just punch it in the right order and don't put extra parentheses or anything, and it'll give you the right answer. Oh, for the micro? I made it a pull down. That was. So I made a pull down. So, trailing zeros, the question you're asking yourself is, is there a written decimal?
Yeah.
There is. They do. Doesn't matter where they are. write exact,
Okay,
or you can write infinite.
okay. Cause this,
See, these are, they're supposed to be tricky.
yes.
Cause this one tricks you because it's a whole number.
Yes, I was gonna say,
Right?
this one tricked me too.
Yeah.
Well, real quick. Okay, so this is one sig fig. So I don't know.
But how many significant figures does each of the things you're dividing have?
Two.
Two. So then what do the rules say?
Well, I need to have two,
You should have two.
but I have one, because that's what I got for the answer, so I don't know where it'll be.
Well, that means that that first zero is a significant digit.
This one?
You've got the one and the zero, those are your significant figures, and the rest are just space fillers. So, the only way to indicate that one of the zeros is significant and the others are not is to put it in second notation. How you gonna- Yeah, Celsius, I believe, is with an S. CELS. Okay, you could do Kelvin, it would be weird. So what's the rule for Kelvin zeros? So you can. Yep. Any questions? So what I do is and then that next digit that I'm getting rid of is it 5 or greater? So that means if this is closer to 313, then it is not. So you write 13. And then what happens when you set it?
I tried a couple of different answers, and it's all one of them. So, it's like literally almost actually all the way to
Okay. That's correct. Yeah. So with this one, it's a whole number, and so that makes us think, well, maybe it's significant. But what does King's Calvin? Those are things, and those are units of measure. So there's no such thing. And so, there are two answers that I would accept for that one, I would accept the one. Or. Is there any uncertainty when you count 25 times? So counting of discrete objects. How many pieces of paper? 1, 2. Are you sure it isn't 2.7? Yeah, we're sure it's two. It's two things, right? So there's no uncertainty when you're counting objects. So the eggs are objects. And so you've got one egg or two eggs, you can't have 1.5. I suppose you could go, well, what if I broke them, you know? You're gonna have to put whole eggs, put something else in there. Okay. How you guys doing? Questions?
So this one, since the lowest maximum case figure was one, and you do scientific calculations, so it's Jason Street.
for non-zeros, it really doesn't matter either way. And for the zeros, you know, in this class, I'll know what you mean, but if you went, to a chemistry class at a different school, they might not use that convention. Yeah. Yep.
And then for grams, milliliters.
Just grams.
Okay, thank you.
By the way, don't forget, do not forget to round. So if you're round, I just realized that I didn't
Because that's like
round.
saying, well, I have 2 apples plus 3 apples. So the unit is out.
No, I mean, for like, when you start doing these, do not forget to round, because then you're gonna have to read them.
Thank you. I put the exact same thing.
There's no capability. Time into the.
Because the order of operation thing with PEMDAS, the addition and subtraction are whatever order they are in the problem. It's not that you always do that.
Do we use PEMDAS? I heard you talking about it in the session.
Right.
I didn't really hear fully.
So, PEMDAS is a good thing, but you don't really need it that much in chemistry. So, like here, we put parentheses around that, right? So, if it's in parentheses, you're gonna do the parentheses before you divide. You're not gonna take this and divide it by that, right? So, that is PEMDAS. What messes people up is with things like this,
Yeah, I was gonna do that.
and they say, oh, well, I'm supposed to do the adding first and then the subtracting. No, the adding and subtracting are together. It's the order. So it's this minus this plus that, just like it's written. If we wanted it to be minus the sum, we'd have to put parentheses around it. Yeah. laptop so you can check your answers. One? Anybody else?
All of them, that's how you store.
Just remember trailing zeros on top or some decimal. So what you wanna do is you wanna convert this.
Okay, so how I do it,
Six.
oh my God.
It's not 3,000 meters squared because
So what I just put it in and then this is.
you don't want that.
and-
Like, you mark it wrong.
Okay. No, I can't do that stuff.
You're rounding it down so that you can get to this one. This one's sharp. No. It's got two multiplications in it.
So this is correct, right? So underline the third digit. And then you look at the next digit. So then,
Wait, I don't even know, right?
Just a minute.
Yeah.
You got a question?
Yeah. It's about this one. I don't know if I can sit around here somewhere, 'cause I got, no, the problem was that I couldn't get the right amount of sick days, it was too less.
So let's start by writing down what the calculator gives us.
Does that answer that I divided it by?
Okay, so write that down. You know you need 3 sig figs, so
Yeah.
go more than 3 sig figs. Okay, so then, underline the third sig fig. So that's where you're stopping, the sig figs, right? Is that higher than the ones place?
Yes.
Yeah. That means it's best to put it in scientific notation first, and then round it.
Oh, okay, that's what it
Then you don't end up with the trouble with zeros.
Okay.
Okay?
Yeah, cause I rounded up and then I was left with, cause it went up again to 4.8.
Right.
you
And
know.
so then you would have 2 zeros, but one's significant and one isn't.
Yeah.
And how do you do that? Scientific notation.
So when it's, adding subtraction, so counting sig figs, do you do the subtraction first and then count the sig figs of that answer?
Yeah, so what you
And
wanna,
divide?
yeah, so what you wanna do is you wanna do the subtracting and then actually write the number down. The whole number that the calculator gives you, and then identify where is the last infinite figure in that.
And then is it like parentheses first when you do this? Like,
Yes, so
start
parentheses
with
would
that
be
and then-
first.
Yeah, for each problem, right, so, okay, so, in this problem, so that you just, these parentheses, like, I would do this for the
Yeah, and so here the parentheses are just to set aside that number of
That's the
scientific
scientific
notation.
So, and this one too, so,
So it's 2.023 minus 1.8 times 10 minus 30. And that all was in parentheses, the brackets. You can finish that and then divide.
and then count the significant figures of that number.
Right.
Then divide by that number and then.
Yeah, and so this one's tricky because you're subtracting, and one's in scientific notation and one isn't. And so that's a place where you need to look at the scientific notation number in decimal notation, just to see how many decimal places it's.
So would you just like do that, and turn it into a decimal and then see what that is, and then you would do that, wait, why would you do that, to change it into the decimal instead of?
Because when I'm subtracting from 2.023, to find the sig figs, I need to know how many decimal places it has. And this changes where the decimal point is, so I can't say, well, that has 1 decimal place. No, it doesn't, it's actually 0.0018, it's got 4 decimal places.
Okay,
Yeah, so that's a.
that one, yeah, I saw it and I was like, okay, let me figure out the basics so that I can
Yeah.
get to